Hi friends, welcome back to Wisdom Academy YouTube channel. In the previous session, we learned what is Coulomb's law. We also learned what are the limitations of Coulomb's law, and we saw what are the basic properties of charges. Today, my topic of discussion would be principle of superposition. But before I enter into this topic, I want to give you a small work. So what you will do, you will go and find out what is the relationship between the gravitational force and the electrostatic force. If you remember what you learned in 11th standard, you would have learned that the most strongest force is nuclear force. Am I right? And you would have learned that gravitational force is one of the weakest force. So now I want you to find out how much weak is gravitational force compared to electrostatic force. It is very simple. I'll just give you a hint if you want me to give. The hint can be that we know the formula of gravitational force. What is that? F is equal to G m1 m2 by r square. And what is the formula of Coulomb's force? F is equal to K q1 q2 by r square. What you will do, you will find the relationship between this gravitational force and electrostatic force, and then you will get an idea what is the ratio between these two. For your help, let me tell you that here you can take mass of an electron and a proton. Even you can take proton and you can check. It's up to you. For reference, I'll just let you know that mass of electron is equal to 9.1 into 10 to the power minus 31 kg. And mass of proton is equal to 1.67 into 10 to the power minus 27 kg. No need of using it because it will get cancelled when you take the ratio. I hope you remember the value of K, 9 to 10 to the power 9, and value of G, 6.67 10 to the power minus 11. So using all these values, I want you to work out and find the ratio of Fg and Fe. You will find it out and you will come to know how much strong is electrostatic force. Coming back to principle of superposition, what we learned in the Coulomb's law. Coulomb's law was given for only 2-point charges, if you remember. It was F is equal to K q1 q2 by r square. Do you ever think that what will happen if there are more than 2 charges? If there are 3, 4, 5, n number of charges, then can we apply Coulomb's law? We can apply with the help of principle of superposition. So principle of superposition is applied when you want to find the force on a particular charge due to the presence of n number of charges around it. For example, if suppose I have a charge q1, I am assuming it to be positive charge, everything to be positive here. I have another charge which is q2. I have another charge which is q3. And let me have another charge which is q4. I wish to find what is the electrostatic force acting on one due to all these charges. I can find. See, I am assuming everything to be positive charge. Everything to be positive charge. If everything is positive, what will happen? What will be the effect of 2 on 1? The force will act on this direction. Am I right? Because it will repel it. And how I will write this force? I will write F12. That is electrostatic force on the first charge due to second charge. Same way, this third charge will also give a repulsive force on this. I will write this force as F13. That is the electrostatic force on the first charge due to the third charge. And the similar way, this Q4 will also give a repulsive force, and I will write this force as F14, which is electrostatic force on the first charge due to the fourth charge. Now, the net charge acting on the net force acting on the first charge, that is F1, can be written as F12 plus F13 plus F14 in this case, and if it is more than this, it will be F1n. Students, you should not forget, it is vector addition, it is not algebraic addition. we cannot do 3 plus 4 plus 6. We must take the vector addition of all these things. And I hope in 11th standard you studied what is vector addition. Vector addition, if I recall, it can be found f will be equal to root over f1 square plus f2 square plus 2 f1 f2 cos theta. So you must know the angle between the two charges to find its resultant. For example, in this case, you can take any two charges. Suppose I am taking f13 and f12 first. Of these two charges, I will find one resultant. And then in these two charges, I will find another resultant. And that would be my final f. So I will not add just algebraically these three values. Rather, I will find the vector sum of all these things. This is how a principle of superposition is used. Let us see an example now. So this example has been taken from NCERT for your reference. Consider the charges Q, Q and minus Q placed at the vertices of an equilateral triangle as shown. What is the force on each charge? So I have three charges now, Q1, Q2 and Q3, which are placed at the vertices of an equilateral triangle. It means the angles are 60 degrees. Now what they are asking? They are asking you to find what is the force on each charge. So what is the force on Q1, what is the force on Q2 and what is the force on Q3. So one thing is very sure, that these two charges are positive, they will repel each other. So first let me find what are the forces acting on Q1, Q2 and then I will talk about Q3. So what are the forces acting on Q1? So this Q2 will repel it. Am I right? Let me name this as F12. That is the force on first charge due to second charge. Then what would be the force acting on Q1 due to Q3? See, this plus charge will be attracted towards that. Why will it be attracted towards it? Because they are unlike charges. It will have attraction. And what will be the force? How I will write? F13. So force on 1 due to charge at 3. Now, these two forces, what will happen to them? How will you find the net force? Net force will be a vector sum. So it will be somewhere here. That is F1 I will write. One thing is very sure, that F1 will be parallel to this line. If I name the whole thing as A, B and C, then I can very conveniently say that F1 will be along AC. Because the figure is very symmetric, we can get a clear idea about it. If you want to verify, you can even verify by finding the angle of the resultant by using the tan inverse formula. Same way on C, B will give a repulsive force. So I can write this as F21. So force on charge 2 due to 1. This will be attractive force and this will be written as F23. That is force on charge 2 due to third charge. And its resultant will be in this direction. I will name it as F2 and that will be parallel to AB. What about charge at A? This being negative and both being positive, on both the sides it will have an attractive force. Let me name it as F31 and this as F32. What would be the resultant of these two? It will be lying somewhere here. Let me name this as F3. So my dear students, first you should understand all these things very clearly, that how these forces are being resolved. If you still have problem in resolving the forces, you must go back to 11th and study vectors. You will also see my video in 11th lectures where I will be talking about vectors. Meanwhile, you can also refer to books and learn what are vectors. So how this F1, F2, F3 is coming, all is because of the vector laws of addition. I am using parallel law of addition here. Fine. So now let us put all these things into a numerical formula. So what would be, first I will find the force on charge 1, that is F1 I am trying to find. What would be F1? F1 will be equal to what? F1 will be equal to root over F12 square plus F13 square plus 2 F12 F13 cos, what is the angle between them? Tell me students, this is 60, this will be 120, isn't it? So it will be cos 120 degree. One more thing for your knowledge, I'll tell you, all these forces F12, F13, F32, F23 will be equal. Why will it be equal? Because all the charges are same. Q1, Q2 and Q3, they have same magnitude Q. So I can replace everything by a common thing F, and I can write F square plus 2F cos 120 is minus 1 by 2. Isn't it? Again, if you're not understanding how this is coming, you must go and look back to your trigonometry basics. Okay, now what it will give to me? It will give to me as root over F square plus F square plus this 2 will get cancelled. I'll get minus of F square. I'll write it here directly, minus F square. These 2 gets cancelled and I get root of F square is F. So what is the net force on the first charge? It is F. Remember that whenever you are writing vector, we must write a direction also. So I told you direction of F1 is parallel to AC. So I can write here AC cap. In everything I can write. Right from here I can write AC cap. So I can write very conveniently that the force F1 is F AC cap. Similarly, you can find and tell me what will be the values of F2. It will be exactly same because it is having the same things. F21, F32 will be F, and F2 will have same F square plus 2F cos 120. So I can write directly here, I'll write here similarly, F2 would also be equal to F. But what will the direction? Will it be AC again? No, it will be BA. So I'll write here BA cap. This is the value of force on the second charge. And what would be the force on the third charge? See, so force on charge 3, that is Q3, that will be equal to F3 will be equal to root over F1 square or F31, or directly I am writing F square plus 2F cos. What is the angle between these two now? The angle is 60 degree. So cos 60 degree. And what is the direction of this? Since it is not known to me, I will write it as n cap. So I can write n cap, and I will define later what is n cap. So what now I will get? It will be root over F square plus 2F square. What is cos 120? What is cos 120? It is 1 by 2. So into n cap. 2 gets cancelled. I get root over 3F square into n cap. So what is the third force? Third force is root 3F n cap. Now here if you want you can define n cap is the direction of third force which is bisecting angle, which angle? BAC. So this is the direction of F3. Let us see one more question. Charges of plus 5 microcoulomb, plus 10 microcoulomb and minus 10 microcoulomb are placed in the corners of an equilateral triangle ABC, having each side as 5 centimeter. Determine the resultant force on charge A. So they have taken 3 charges, plus 5 microcoulomb, plus 10 microcoulomb, minus 10 microcoulomb. Add these 3 vertices of an equilateral triangle. They are asking to find what is the net force acting at A. So same way how we did the previous question, if you proceed in this, see on A, what would be the force due to B? It will be in this direction. Let me name this as FAB. What will be that? Force on A due to B. Why I have drawn in that direction? Both are positive, it will repel. Right. Now this A will get attracted towards the C because they are unlike charges. So I'll write here as FAC. That is the force on A due to the charge at C. What would be its resultant? Definitely it will be somewhere here. That is called F at A. And can you tell what will be the angle between FAB and FAC, yeah, it is 60 degree, it will be 120 degree. So if I find FAB, FAC, then using the parallelogram law of addition, I can find FA very conveniently. Let us try to find each thing. I will not do it entirely for you. I'll just show how to start. You have to do by yourself, right? So if I start doing it, what is FAB? FAB is equal to K. What is Q? Q1 is 5 microcoulombs. I'll write 5 into 10 to the power minus 6. I hope you know micro is 10 to the power minus 6. And second is 10. 10 into 10 to the power minus 6 by r square. What is r between them? 5 centimeter. Convert to meter, 0.05 the whole square. And since I have written the vector sign here, what is its direction? It is along BA. So I'll write BA cap. Is it fine? So K value also can put. What is the value of K? K value is 9 into 10 to the power 9. So put everything and find the value of FAB like this. Same way, you will find FAC. And what would be that? K. Charge values are 5 into 10 to the power minus 6. Again 10 into 10 to the power minus 6 by 0.05 the whole square. But what direction it will be? It will be having a direction of AC cap. So I'm not writing CA cap because from A towards C. Now, if you see properly, they both will have almost same magnitude because the values are exactly same. So when you put this, you will get the value of this. This will be along BA cap. This will be along AC cap. Finally, you will get the value of FA as how I told you just now, root over FAB square plus FAC square plus 2 FAB FAC cos 120 degree. So when you put the values, you will get the answer. I am not doing it for you because I want you to practice by yourself, and it is just basic calculation. There is no much technical things involved inside this, so I am leaving it on you. One more thing I want to tell you is that there are lots of questions from these areas. I have taken only 2 examples for you, but there can be questions where there will be a square, or there will be a rectangle, or there may be a straight line, and the charges will be kept. And just by using the vectors, you can find the resultant. So to be very frank, this chapter, this portion, you will be comfortable only if you are very strong in vectors. That's why I am repeating again and again. Please refer vectors if you are feeling difficulty in this. If you understand what is vectors, all these things becomes very easy for you. Now we are going to see some questions which were asked in competitive examinations like AIMS or NEET. So this question was asked in AIMS. The question was, 2 charged spheres separated at a distance d exerts a force F on each other. If they are immersed in a liquid of added constant 2, then what is the force? It's a very simple question, you know. I mean, this question, by seeing my previous video itself, you can do very conveniently. There is nothing in this question. See, they have told that there are 2 charged and they have a force, maybe I am taking it as attraction, it can be repulsion also, F. Now, when the same 2 charges are kept in a different liquid, which is having epsilon r as 2, what is the value of force? You remember what we learned in the previous class? Dielectric constant epsilon r is equal to F vacuum by F medium. Here the medium is liquid, so I can replace this medium by even liquid. What they asked you to find? Force. So what would be F liquid? F liquid will be equal to F vacuum by epsilon r, that is dielectric constant. What is F vacuum? F vacuum is given as F, epsilon r is 2. So the answer is F by 2. As simple as it is. This question was also asked in AIMS. 3 charges plus 4q, q and small q are placed in a straight line of length L at 0, L by 2 and L respectively. What should be the q in order to make the net force on small q as 0? If I draw it in a diagram, straight line at 0, at L by 2 and at L, I am placing 3 charges, that is plus 4q, q and q. This is at a distance of L by 2 and the complete distance is L. That information is given in the question. What they are asking you, what should be the value of Q in order to make the net force on small q as 0? Let us try to find that. Since they have given net force on Q is 0, just equate it to 0. So what is the net force on Q first? So net force on Q will be equal to K. First, these two will give a force, these two will give a force, and both will be added up. So I'll write K 4Q Q by, what is the distance between this 4Q and Q? L. So I'll write L square plus K capital Q small q by, what is this distance? It will be L by 2. So L by 2 the whole square. And they have said this force is equal to 0. The moment I do this, I'll get the answer. Let us try to do that. So I'll get K 4 Q square by L square is equal to minus K Q by L square. I'll make 4 to go above. Is it fine? Now see what gets cancelled. This gets cancelled. This gets cancelled. K gets cancelled. K gets cancelled. 4 and 4 gets cancelled. 1 Q, other Q gets cancelled. So what I get? I get capital Q should be equal to minus Q. So when capital is equal to minus Q, then the net force acting on the charge small q will be equal to 0. Can you see how easy the questions are? So for up to where I have taught you, I am taking some competitive questions from these areas, like from force, from superposition principle, and you can see everything is easy. If you understand the concept, everything will look easy to you, right? So in today's lecture, what we learned the principle of superposition. Then we solved some few numericals based upon that. I also gave some insight about how the questions can be asked in competitive examination. And if I remember in the beginning, I told you to find the ratio of gravitational force with electrostatic force. Please do that. Whatever works I am saying to you, only if you do that, you will learn more. And mind that whatever we are doing on the board is not sufficient for you. I am just giving an insight, I am just giving some concepts. You must go back to home, open the NCERT book, solve the questions, use other reference books, solve the questions. Only that will produce results. Thank you with this. Next class, we will see about electric field. Thank you.